So this is one of the primary reasons I purchased this Jackery thing, is chest freezer. This is a lot of food, and you don't want it to go bad, you know, especially nowadays. You know, I bought this primarily because of the COVID, didn't want to go food shopping. I'm like, fuck this, I'm just going to buy a bunch of food and store it like my grandparents used to do. They used to have one in the basement. I don't anticipate the Jackery having a problem with it. As you can see, it's still drawing 3 watts, just the inverter by itself. The chest freezer is plugged in, but I don't see how I'm going to make this thing turn on, because it doesn't. I don't know when this turns on. You basically have to. Oh, something just kicked in. No, it didn't. That was the air conditioner. Yeah. So, honestly, I don't know how I'm going to test this one. I'm just going to have to wait for it to warm up enough so it turns on. But that's a good thing, because if it won't turn on that often, then it's not using that much power when it does turn on. Oh, we have a switch down there. We could turn it lower. Yeah, let's do it. It's like somewhere around max. Minimum. Wrong way. Dipshit. Okay, just turned on. How much are we drawing? Gotta be kidding, that's it? That's not a lot. 80 watts, that's it? 80 watts. Man, the battery lasts forever on that one. Now, and you also got to consider that, you know, the chest freezer turns on and off, on and off, on and off. It's not going to be on constantly, not like the air conditioner. 83 watts. You do the math. And then say intermittent, so basically we'll be turning on and off. Yeah, this is an easy one. I'm probably going to turn this off because I turned it too cold. Let's see, max. I think it was somewhere around here. Yeah, probably I'll have to check temperature. Yeah, very nice. That's what it's primarily for, is emergency stuff. It'll run lights, it'll run TVs for 14 hours, it'll run my DJ equipment, it'll run some small power tools and everything like that. By the way, this is not part of it, I just put that in there so I have a few extra USB ports. You got USB-C, USB-C, 2 regular USBs, one's a fast charge, 3 AC outlets, and the power input. I started this test at about 98%, and after testing all these items down to 89%, which is pretty good, still drawing 87 watts. Probably gonna leave it there. I had this nicely calibrated to like -4, but oh well, do it again. I had to make the compressor kick in. I was just really curious how much power it draws. I mean, you can get something called a kilowatt meter, and you plug it in, and it'll tell you. But here, it's coming up pretty quick. Some of the reviews saying that this number does not react quick enough. I don't see that problem. That must have been an early demonstration unit. This one's fast, so don't believe that. 87. Turning on USB doesn't really change anything. Yeah, I mean, this is really, really cool. My idea is basically keep the Honda 2000 watt generator in storage or whatever it is, you know, or whatever, even the closet. Power goes out, grab the Jackery, hook it up, power whatever you need. The next day, take it, plug it into the Honda, charge it back up again. You can charge and use it at the same time, but you can't draw more than 160 watts because I think the max you can input on this is 160. At least that's so far what I've seen. I'm going to experiment with different power supplies and voltages and see if I can get a little. You can also only use 1 or 2. You can't use both at the same time. The 1000 here has an MPPT charge controller, which means what that does is you have PVM and MPPT, pulse width modulation, and MPPT is max power or something. The difference is that the MPPT takes whatever voltage you feed it and will adjust the charge to try to optimize it as much as possible. So you get a faster charge with whatever voltage you put in. So this thing will go somewhere from 11 volts all the way up to 30 volts, anywhere in between, and it will charge appropriately. Whereas a PVM charger, if you drop low, 9, 10, 11, it just basically doesn't charge at all. It doesn't give you anything, where this one will do charging. Now, a lot of these power banks actually charge extra money for the MPPT charger. And the fact that they built it in is a real important thing. Because the next video you'll probably see is a solar panel, which I can't show you today because there's no sun, it's raining. And it's only 120 watts, but with the MPPT charge controller, it should charge it fairly quickly. Within a day, I'm thinking I could charge this up, you know, at least a good 75–80%. I don't think I really need 2 of them. But you could put 200 watts in and we'll probably charge it 160. So you're kind of wasting 40 watts. And they have to be in parallel, because if you put 2 in series, you'll blow it up and won't take it. So, the next video, I'll explain what I like about this, more of a review itself, and why it chose this one over the other model. But we're done testing. If anybody wants to see anything tested, let me know. I don't have a ton of kitchen gadgets to really test, but I know it'll run lights, TV, cell phone chargers, charge my laptop, Bluetooth speaker, you know, big stuff like that. No problem at all. No problem at all. But I want to try some of the high current stuff, you know, and it's past everything.